Alright, hi everybody. Welcome. We are going to get started with this review. First part is graphing. Make sure when you're graphing these exponential graphs, you make sure that you use the asymptote. Okay, never forget to draw in the asymptote. So my suggestion to you is to use a highlighter. So the asymptote is always your k value. So if you highlight at that k value, you'll know where your asymptote is, and you'll know that the graph can't go below the asymptote. Alright, so now you would go to your calculator and get a nice table. So I like to pick numbers that are not going to give me a decimal. But you really don't have too many choices there. So I started at -2 and 4.12, -1 and 4.6, and 0.7. So we plot those. You can see you don't really get a lot of room on the left, but make sure that you don't touch the asymptote. So you see how this red line is not touching the asymptote because the asymptote is like a barrier, so you can't touch it. So your domain has double arrows, which means it's -infinity to infinity or all real numbers. Your range is always asymptote to infinity, so it's going to be 4 to infinity with parentheses. X-intercept is where it crosses the x-axis, so we would say none. Y-intercept is where it crosses the y-axis, and that happens at 7, so this is your y-intercept. And your asymptote is at y equals 4. Don't forget the y equals. And that's how you graph that one. Alright, now for the next one. You're going to look for the k value. In this case, the k value is -2. So I'm going to draw my asymptote at -2. So I know that I cannot go below my asymptote. So I come up with a nice table. And I can actually start this table at -1, 2, 0, -1. And then after that, it's all decimals. So it's 1 and -1.75. Remember what I told you. Try not to touch the asymptote. Okay, so there is your graph. Double arrows on both sides means that our domain is going to be all real numbers, or you can put -infinity to infinity. The range is from asymptote up to infinity. The x-intercept, this is when you go to second trace, number 2, left bound, right bound, enter, enter. Or you can go to second trace, number 5, enter, enter, enter. But this is only if y2 equals 0. You can use this version. If you forget to do y2 equals 0, you can do this way. Both of them will give you the same answer, and that answer is -0.5. So it crosses the x-axis at -0.5, crosses the y-axis at -1, and the asymptote is y equals -2. Okay, next question. You're going to look for your asymptote. So the asymptote is at -3. So you just have to make sure that your graph does not go below -3. Now, since this is an E, most likely you're going to have pretty much all decimals. So you have I started at -2 and -2.9, and then -1 and -2.6, 0, -2, and then they just got to be really small decimals after that. And then the next big number was at 2 and 4.3. So you can go up there. But there's your graph. Again, your domain is all real numbers. Range goes from asymptote to infinity. X-intercept is right here. So what we need to do is do our second trace. Either second trace number 5 if you made y2 equal to 0, or second trace number 2. And you get 1.099. So make sure that when you have your graph hitting the x-axis, that you get an x-intercept. Y-intercept is right there at -2. And then the asymptote is at -3. Okay, last one. And notice in all of these problems I have not forgotten my asymptote. Here my asymptote will be 0 because there's nothing as a k value. So I need to make sure that all of my graph is above the asymptote. The only time that your graph is below the asymptote is when you have a reflection. So the table won't be as nice. I have -1 and 5.4, 0, 2, and then 1 and 0.7. So really not a lot to work with here. Okay, so just because this is a decay doesn't mean that your range changes. Your range is still going to go from asymptote up to infinity. Domain is the all real numbers still. It never hits the x-axis because that's where the asymptote is, so we say none. It hits the y-axis at 2, and the asymptote is y equals 0. Alright, so that concludes the graphing section. Make sure to rewind this video just in case you have any questions on graphing. Now for growth and decay. Growth or decay is indicated by the b value. The b value is what is in the parentheses. Since 7/5 is improper fraction, that's a growth. Since 1.31 is bigger than 1, that's a growth. 0.45 is smaller than 1 but bigger than 0, so that's a decay. 6/7 is a regular fraction, meaning that it's smaller than 1 and bigger than 0, so that's a decay. Alright, for the next two, these are e. E's, you can't look at the b value because the b value is e. So you actually have to look at the exponent. If the exponent is positive, you would write growth. If the exponent's negative, you write decay. That is the only time you look at the exponent. For all of the other types of problems for growth and decay, please look at the b value. Alright, next section is looking for the percent of increase or decrease. Please put this formula to memory as we will not be giving it to you. b minus 1 times 100. And when I'm talking about b, I'm talking about the value that is in parentheses. That's b. B is also your growth or decay factor. So for instance, this says 0.3, so 0.3 would go here. For the next one, 1.25 would go there. 3/8 goes here, and 0.54 goes there. Get that out the way right away. If the number that you wrote in that second space is less than 1 or bigger than 0, it is a decay. So this is a decay, this is a decay, this is a decay. If your B value is greater than 1, it is a growth. Okay, now your percentage rate, you use your B minus 1 times 100. So you're going to do 0.3 minus 1 times 100. That gives you negative 0.70 times 100, which is negative 70. Remember, when there's a negative, you replace that negative with the word decrease. So drop the negative and put decrease in its place. Same thing here. We have 3/8 minus 1 times 100. That's negative 0.625 times 100 is negative 62.5. Drop the negative and replace it with the word decrease. Now here you're going to have 1.25 minus 1 times 100, which is 0.25 times 100, which is 25. So this is a 25% since it's a growth increase. And the last one would be 0.54 minus 1 times 100, which is negative 0.46 times 100 gives you negative 46. Remember, drop the negative and replace that with the word decrease. Okay, watch everything that you do in this section because it's definitely, the work does matter. Alright, now for word problems. Word problems are all based off of y equals ab to the x, and b is either equal to 1 plus the rate or 1 minus the rate. You don't do the other formula until it's talking about compounding. So in this case we have y equals 65,000 times 1, and they're talking about that the value has decreased. So we do 1 minus, that's for the decrease. And then you change this to a decimal by dividing it by 100. And you get 0.0118. Now since they're asking for a function, you should have an x here. Make sure that anytime you see the word function, you have an x. Now how much is the car worth in 2005? That is 15 years after 1990. So just plug in 15 for x. Notice where the 15 goes. And then you can just solve. Now you don't have to do this second step. This is fine. But just put that in your calculator. And you find out that the car is worth $54,398.40. So make sure you show your work. Okay, last question for this video is number 16. So this video will only have 1 to 16, and then the second video will have from 17 to 30. That way you don't have to watch it all at once. Alright, so house is bought near river, and it appreciates. So because it appreciates, you're going to use 1 plus the rate, and make sure you divide that by 100. So the function would be 665,000 times 1 plus the rate, which is 0.072. And make sure that you put an x in because they're asking for the function. Now how much will the house be worth in 20 years? That's when you're going to plug in 20 in for x. That's when you plug in the 20. So you can take it one step further if you want. You don't have to do this. You don't have to do this part. because you can just put it all in your calculator. And you get that the house is worth $2,671,267.33 after 20 years. Alright guys, so that concludes video 1. So in video 1, remember with graphing, we talked about don't forget the asymptote. And then the second section for growth and decay, remember to look at the B value. The next section was growth and decay percentage rate. So that formula is B minus 1 times 100. And remember, your growth factor or decay factor is always your B value. Okay. And then the last section with the word problems, you use 1 plus the rate for B, and that's for growth. And you use 1 minus the rate for B, and that's for decay. Alright everybody, good luck.